Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about Algebra 2, Chapter 3. This is a review that was many problems. It's 30 problems. We're only going to do about 12 of them because we're only focusing on a specific portion of this review. This is solving using factoring or completing the square or square roots or quadratic formula. And the first two is just factoring, next two are square rooting, things like that. And also, we're going to take a look at reviewing nonlinear systems. So, we're just going to get right to it. Right off the bat, I know that anytime I go in and factor anything, I always take the number, like the constant, and I find all of the factors of 16. I have been doing this for many years, and I still do this for every single problem that I solve because it just makes my life easier to see the answer where I have it, right? So I know 2 and 8. So I'm going to factor by opening up two sets of parentheses. I know x times x is x squared. I know 2 times 8 is 16, and then 8 minus 2 is 6. So I'm going to go plus 8 minus 2. And because it says solve instead of just factor, what I need to do is I need to actually set each of these equal to 0. So I'm going to have x plus 8 equals 0, x minus 2 equals 0. So x is going to be negative 8 and x is going to be regular 2. And that's it. I'm done for this problem. The next problem, I'm going to actually change colors because I think it's going to be too much of the same color all over the place. I want to make sure that I have everything over on the same side. And I also typically don't want this to be a negative x. So I'm going to add x squared to both sides and I'm going to subtract 24 from both sides. So these will cancel and I'll be left with 0. And then here I'm going to have this. So I really like seeing this because started looking at this problem originally. I was like, oh my gosh, 4 and 6 for sure. And then I was like, wait a second, you can't have a negative 4 and a positive 6 or a negative 6 and a positive 4 that add up to positive 10, right? Because I know that I have to have a negative number that they multiply to, so one of these will be negative. So this would not be an option. If I would have seen it, I would have been like, oh, obviously this is not an option, right? So I'm really looking at this 2 and 12. So again, I'm going to open up both sets of parentheses. I know x times x is x squared. That's where I'm getting that from. And then I know because I want it to be a positive 10x, I'm going to do plus 12 minus 2. And then I'm going to set each of these equal to 0 to get my final solution. And then I have negative 12 and regular 2. So you could write it in two separate things or in one thing that's together. Both are totally acceptable. Okay, so this actually, it says solve by square rooting. I should have written the instructions, but when you have the actual worksheet, you'll see those are the instructions. So in order to solve by square roots, I want this x squared by itself. So I'm going to subtract 49 from both sides. And I'm going to be left with x squared is 36. And then I just go in and I square root both sides, call it good. This is a problem that's going to be on the easier side because we know that 36 is a very plain Jane number. It's a perfect square. It's got positive and negative 6 as its roots, as its factors, right? For this particular problem. Number 4 is where things start to get a little tricky because there's more math that you need to do before you can go in and square root. So if I go in and I subtract 1 from both sides, I end up with 3x plus 1 squared. And again, I want this x squared to be on its own. So I want this whole thing to be on its own so I can eliminate this perfect square. So that equals 24. I also know that I can factor out 24. I can maybe not factor out, but like when I square root both sides, I can get prime factors going. So I know that 24 is 4 times 6 and 4 is 2 times 2. So that's a pair that's going to go out of the radical. But because 6 is just 2 times 3 and there's no pair, I'm going to leave 6 inside of the radical. So I'm going to end up with 3x plus 1, right? Because the squared is going to cancel by the square root. And this is going to become positive and negative 2 because I'm pulling the 2 out of the radical, root 6 because that's what 2 and 3 multiply to. Then I need to go in and subtract 1 from both sides. So I'm left with 3x equals negative 1 plus or minus 2 root 6. And then I need to divide by 3 on both sides. So x is equal to negative 1 plus or minus 2 root 6 over 3. Now, as an Algebra 2 student, problems like this are going to look very gross, in my opinion. And I know I've talked about this so many times in all of the videos that I say, the further you go in math, the more disgusting your answers are going to be. Like, this does not look like a very beautiful number. Like positive negative 6, the answer for number 3, so pretty, so like concise, but this is like too much, right? We've got decimals, they're going to be irrational. There's going to be so many things happening. But it is a very typical answer for an Algebra 2 problem. So if you see something like this as an answer, I would not be like, oh my God, I did it wrong. Like if you're an Algebra 2 student, you probably did it right. It's just the way of the world, you know. Also, one more thing I would like to say about this is number 3 is more of an Algebra 1 problem. Number 4 is more of an Algebra 2 problem. Okay, so 5 and 6 we're asked to complete the square. So one of the things that we always want to do when we complete the square is we want to make sure that we're getting the x's on one side and the number on the other side. So I'm going to real quick subtract 7 from both sides and subtract 6x from both sides. So that way these guys will cancel and I'll have my x squared and 6x on the same side. And I know eventually I'm going to need to add the same thing to both sides of the equation. So I'm just going to go ahead and put it in right here. I also know that the thing I have to add to both sides of the equation is going to be b over 2 squared. Now, one of the things that I really, really strongly encourage for students to do is actually write this step out. Now, in most cases, I'm not like, oh my God, you need to write this out. You need to do this math on paper. Like, not always. Sometimes you do. This is one of those times where I'm like, I strongly advise that you do that, only because it's going to be super, super helpful for when you go in and do problems like this with fractions. Now, when I did the work for both of these, neither one of these had a fraction. Neither one of these had a fraction where I had to factor things out, but they did show up where I was like, it's worth it to have this conversation in this video to leave it some space. Okay, so that being said, I've got negative 6 divided by 2 squared. So negative 6 divided by 2 is negative 3, and I'm going to square that and get 9. That means I'm going to add 9 to both sides. So now I'm going to take this kind of over here. This was kind of like my side work. Typically, when I do this work and I have lots of space, I do it kind of over on the side, but then I leave this. This is the number that I really, really, really want because when I go in to factor this, I already know that this is just going to be x minus 3 squared. I don't have to factor by setting up 2 sets of parentheses. I can just go straight in and go x minus 3 squared. And then when I add these two, I end up with 2. So now I'm kind of in this position where I was, where I need to eliminate that perfect square, right? That's with the square root. So I'm going to eliminate that. These guys will go away. This will become square root 2. So I'm going to end up with x minus 3 equals positive negative root 2. And then just add the 3. So I'm going to have 3 plus or minus root 2. Final answer. Again, is this very typical of an algebra 2 answer? 100%. 100%. Okay, so now I've got this other problem, which also says solve by completing the square. But before I start to solve by completing the square, I'm going to actually divide everything. Hold on a second. I wanted a blue marker. Okay, I want to divide every single one of these terms by 4 because I know they're all multiples of 4. And when I do something to one side, I have to do it to the other, right? So I'm just going to do 0 divided by 4. So I'm going to be left with x squared plus 2x plus 3 equals 0. I know I need to get the x's to one side, so I'm going to go x squared plus 2x plus some unknown for now equals minus 3 plus some unknown. And this became a minus 3 because I just subtracted 3 from both sides. Now I'm going to do the same thing, add b over 2 squared. So 2 over 2 is 1, and then 1 squared is just 1. So I'm going to add 1 to both of these. And then I'm going to bring this about here, and I'm going to say, okay, this is x plus 1 squared equals, this is negative 3 plus 1 is negative 2. So negative 2 is going to be square rooted. And when we square root a negative number, we know that it's imaginary. So these two will cancel, and I'm going to be left with x plus 1 on the left-hand side and positive negative root 2i on the right-hand side. So if you notice, I'm just going to take that I right out of it right away. And then I subtract 1 from both sides, and I'm going to be left with x is equal to negative 1 plus or minus root 2i. Now, I have seen it where it was written negative 1 plus or minus I root 2. It just really depends on what your teacher prefers, okay? But this is kind of like where your answer is, either one or the other. Okay, next set of questions, they want you to solve using the quadratic formula. They do say that some solutions may contain complex numbers, so we'll get there. We'll cross that bridge once we get there. One thing that I need you to understand is that in order to use the quadratic formula, you need to have it memorized, because typically at this point, their teachers are not giving you this particular formula. This is one of those things that you kind of have to have memorized. And I know on TikTok years ago, my students have been like, "Oh my God, Anna, they have the quadratic formula on TikTok right now." And I'm like, "Oh, okay, great." But it does have like a very catchy song. I think it was like a Pop Goes the Weasel song. I don't know. I would just go on to whatever form of video watching you use, whether it's YouTube or TikTok or whatever other social media, and then just search up quadratic formula. It'll show up. It's one of the things that shows up, like very, very first thing for quadratic formula. Okay. So that being said, now that you have it memorized, we want to make sure that we have our A, our B, and our C all on the same side. So I'm going to go ahead and subtract 2 from both sides, but I'm not going to show that work here only because I know I'm going to need a lot more room. I also know that my A is negative 1, my B is 5, and my C is negative 2. So before we continue with this, one of the times that I would absolutely use the quadratic formula is when I have my A is a number other than 1, kind of like in this situation. I would not even attempt this. I would just go straight to the quadratic formula. In this case, when I look at my 2 and my factors of 2, those are just 1 and 2. So I don't really think I can make 5 from adding 1 or 2 or subtracting 1 or 2. That won't happen. So then I'm just going to go in and I'm going to say, you know what, quadratic formula right away. Okay. So now that I have my A, B, and C, I'm going to go and plug everything in here. Um, Typically, I wait till the very end to do this 2A business, only because I know this is going to be a lot more work than just one quick step. So I'm going to go -5 plus or minus square root. So 5 squared is 25 minus 4 times A times C. And since I have three negatives, I know it's going to be 25 minus 8. And 25 minus 8 is 17. Again, a super gross number. So I'm going to rewrite this, and it's going to be -5 plus or minus root 17 over. So because A is -1, I'm going to put -1. Now, sometimes teachers will say, you know what, this is it, final answer. This is not a problem. Some teachers will say, no, no, you have to simplify and divide everything by a -1 so that you'll get 5 plus or minus root 17 over 2. Again, I would pay attention to what your teacher does in the classroom. If they're saying like, hey, this should not be a negative, these two, then go ahead and solve it like this. If they don't care, then this is kind of where it's at. Because I've done this for so long and because I've had experience with so many different teachers, there's so many ways that you can solve the problem just by kind of looking at it and being like, oh, this is my preference. This is how I want my students to solve it. It's just a teacher preference. It's not a you thing, it's a them thing. Okay. So in here, I have everything on one side and it all equals to 0. So I'm going to go straight into my A, my B, and my C. And then hopefully you have your math facts memorized because this is going to be a doozy. So I've got 12, -12 for B. So I'm going to just go 12 plus or minus 12 squared is 144 minus 4 times A times C. This is going to be 144 minus 156. If I remember correctly, 156 is 12. But because this is 144 minus 156 is -12, and that's going to be in the radical. So because I don't want a negative in the radical, I'm going to write 12 plus or minus. And actually, I can break apart 12 into 4 and 3, which will give me 2 and 2. So the 2's will come out and the 3 will stay in the radical. So again, sometimes I've seen it written 2i root 3, and sometimes I've seen it written 2 root 3i. Both are generally acceptable. I don't think there's one that's more acceptable than another. And then I know all of this is going to be 2a in the denominator, so 6. So in here, I can say that, hey, I have a 2 that I can factor out from each of these. This for sure, I would not leave as is. Like this, I would say some teachers have accepted in the past and they're totally fine with that kind of solution. But this, 100% no Algebra 2 teacher is going to be willing to accept this and give this full credit. They might take off a point here or there, maybe even half a point, depending on how much this problem is worth, but they will not accept this as a complete answer. So I'm going to divide each of these by 2. So this will be 1, this will be 6, and this will be 3. So again, your x would either be 6 plus or minus I root 3 over 3, or your answer might be x equals 6 plus or minus root 3 I over 3. Both are completely acceptable. I've seen both in every situation. Okay, so the next type of problem is when we solve using substitution. So this is a nonlinear system. So one thing that you'll notice is that you have an x squared here and then a linear function here. So Because I have y equals all of this business here, I can take all of that and replace it with this y, or replace the y with all of that, I should say. So when I take all of this and put this in place of this y, I'm going to end up with 40 equals x squared plus 5x plus 4. I'm going to subtract, oh, not 36. I'm going to subtract 40 from both sides to get negative 36. And then I'm going to have everything on one side. So minus 36 equals 0. This I can easily factor because I know my factors of 36 are 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Actually, I don't even need to go any further because I know a negative 36 means I'm going to have to subtract, and this is going to give me a 5. If I did go further, it would just be 6 and 6, and that wouldn't give me anything anyway, so I'd still be stuck with 4 and 9. So I have x plus 4 and, sorry, x plus 9, x minus 4. I'm going to set them each equal to 0. And for the purposes of space, x is going to be negative 9 and regular 4. This is part 1 of my solution. Because I have a system, I have to have a coordinate point, an x and a y solution. And when I have, in this particular case, two answers, two solutions, so not just like a regular system where they're kind of like an x and they only meet at one point, nonlinear systems meet in multiple points. So because that's the case, we now have to go in and we have to take these x values and plug it back into one of these equations here to then get our y value. So to be frank, the easiest equation for me to use is this top one because I have y on its own and I don't have to square anything. So I'm going to take the negative 9 and put it into my equation. And I'm going to take the 4 and also put that into my equation. So this will be negative 45 plus 4. So negative 41, which is so gross. And this is 20 plus 4, which is 24, significantly less gross. So again, because I said that we need to have an XY point in order for us to be able to kind of get our final answer, we need to bring the negative 9 and the negative 41 together as a coordinate point. So my final answer is going to be negative 9 comma negative 41 and 4 comma 24. One more thing that I would like to say about this is that when you do give this particular answer, you want to make sure you're putting into the coordinate points into parentheses. If they're not in parentheses, then all they are is just a set of points, a set of numbers. Okay, so this one also said use substitution. Let me just double check. Yep. Use substitution to solve. So in here, I see that this whole thing equals y. So that means in my next equation, wherever I see y, I can replace one for the other. So I'm going to go ahead and get started with this 2x squared minus x minus 5. And then the rest of this equation is just going to be brought in here. So minus 5x equals 3. I'm going to go ahead and combine like terms, make sure everything is set equal to 0. So this can be combined with this, and then I'm also going to subtract 3 from both sides. So now I know that's an equal 0. This is going to be minus 8. These two, when I combine them, are going to be negative 6x and then 2x squared. Before I go in to factor this, I can actually divide everything by 2, which is going to make my life easier. So I'm going to have x squared minus 3x minus 4 equals 0. And the only possible factors for 4 that I have that could potentially even do anything is just 1 and 4. 2 and 2 will not work in this particular situation. So I'm going to end up with x minus 4 because I wanted to add up to negative 3, and then x plus 1. So for the purposes of space, x is going to equal regular 4 and negative 1. So now that I have my x values, I need to go in and plug in my x values to get the y. Frankly, this does seem to be nicer because I do have y on its own, but I really don't want to square things. So I'm going to change that equation to say y equals 5x plus 3. And then I'm going to plug each of these x's into this equation. So my first one, I'm going to have y equals 5 times 4 plus 3, and y equals 5 times negative 1 plus 3. So this is going to be 20 plus 3. Whoops, that's a 2. And then 23, and this is going to be negative 5 plus 3, so negative 2. So again, in order to put my answers, I have to put in a coordinate point. So my answer is going to be 423. That's where that information is coming from. And then negative 1, negative 2, that's where that information is coming from. And this is my final answer. So in here, I have a linear function and a quadratic function, and both of them are going to meet in two separate places. Okay, so the next type of problem that I have in here is solve the system using elimination. Sometimes it's super convenient and super nice, like, oh my goodness, look at this. I could just cancel it out. When you solve a system by elimination, you essentially add or subtract the two equations where they line up so nicely where one of the items is just going to cancel itself out. So instead of having an x squared, an x, and a y, I'm now going to have an x squared, an x, and a number. So I'm going to add all of these equations together, and I'm going to have 4x squared minus 24x equals negative 36. Now, one thing that you'll notice is that all of these are divisible by 4. So I'm going to go ahead and divide everything by 4, and then I'm going to bring that number over to the other side so that I can set it equal to 0 and factor. So this is going to give me x squared minus 6x equals negative 9. I'm going to add the 9. For space purposes, I won't show that. So plus 9 equals 0. And then when I factor this, I'm going to end up with x minus 3 squared, or just x minus 3. And then in here, my solution will just be x is 3. Gosh, there really is not enough space for anything. Okay, so again, when I solve a system, I know that I'm going to have an x and a y value as a coordinate point for a solution. Whether it's solving by substitution, solving by elimination, or solving by graphing, I'm looking to see where my two functions meet. Okay, so in this particular case, I'm going to have two functions, and probably they're going to look like this. One is going to be here, and another is going to be here, and they'll meet somewhere here. Okay, probably not there because it's got to be a 3, so it'll probably be on this side. But just so that you kind of have a general understanding of what's happening. In the last one, we had a linear function, so they kind of met kind of like this in two separate places like that, okay? And that's really all we're looking for is just the points where they meet. Okay. So now that we have our x value, and again, in this particular case, because it only meets in one particular place, that's fine. We're just going to go ahead and plug one variable back in there. I don't love to deal with negative anything, typically. If story time, I did not do very well with integers when I was first introduced to them in middle school, and they were the bane of my existence. So I really disliked them. And now I'm a lot better at them, but I think I still have like some small version of PTSD from integers from way back when. So I will always plug it back into a positive y. And also, why wouldn't you plug it back into a positive y? Like then you don't have to divide by anything, right? So if you don't have to divide by anything towards the end, then great. Like you've solved a problem without giving yourself more work, right? Also, the numbers in the first equation are smaller, so of course I'm going to pick the first equation. And every time I see an x, I'm going to go ahead and I'm going to replace that x with 3. So I'm going to go 2 times 3 squared minus 8 times 3 plus y equals -5. So now you can tell you only have one variable, so ta-da, you can go in and solve that. So I'm going to have 2 times 9 minus 24 plus y is -5. 18 minus 24 plus y is -5. This is -6 plus y is -5. And then I'm going to add 6 to both sides, so y is going to be 1. In here, typically when you have just one solution, leaving it like this is totally acceptable. I do think the preference should be giving a coordinate point. That's my preference, and I've seen a lot more teachers leaning in this direction, whereas maybe 15 years ago, this would have been just fine. Now they actually want the coordinate point. And it may have something to do with the change in standards, who knows? Okay, so this is not very well set up for elimination because you don't have anything really lined up. And if you take a look, like your equal sign is here and here. So you really want something that looks like this, where the x squareds are lined up, the x's, the y's, the equal sign, the constants. Everything is all lined up. And so we want to change this so that we get to a place where we have everything lined up. So if I were to leave this as is here, I would need to make a change here. So I'm going to go in and I'm going to like flip-flop the whole thing, like this whole thing with this y. So I'm going to put -y here. And this -2x is going to go underneath the x, and the 13 is going to go with the 3. Now this is set up really nicely for me to go in and eliminate the y's, right? They'll just get chalked. And so I'll have a 0 on this side. And then I can just add the two things, right? The two equations. So I'm going to have x squared minus 8x plus 16. And in this case, I actually know that this is a perfect square trinomial. So I knew right away that this was going to be 4 and 4, but if you don't know that it's going to be 4 and 4 right away, then you do absolutely do want to go in and put these factors in. So then I've got x times x is x squared, and then it's going to be -4 for both of them because I want it to be a -8. And then I'm going to solve x is going to equal regular 4. Again, I'm going to try to make my life as easy as possible, but as much as I hate negatives, I'm just going to take this initial equation and I'm going to go in and I'm going to divide everything by a -1. So this by -1, this by -1 to make my life easier for the future. So I'm going to have y equals 2x minus 3, and that's when I'm going to plug in that 4. So y equals 2 times 4 minus 3. 8 minus 3, y is 5. Again, you could leave it like this, but I think the trend for most teachers, if not all teachers by now, is moving towards giving a coordinate point instead of going in and leaving it as x equals y equals. I hope that this video was helpful, and I look forward to seeing you in another video. Bye.